Hi guys, back with another video. This is Tuesday. We're looking at graphing rationals. We actually did this last week in class, so this is the homework. It's page 12 of your packet. So this is actually posted on Google Classroom if you just want to check all of your answers. But I'm going to go through one video at a time with each question just because there's a lot happening with these. So just to review, you can just click through the questions that you may have missed or the ones that you may need specific help with. All right. So be patient with me because I am doing a lot of things with this camera right now. But here we go. Okay, so a couple of high-level review things. So first of all, we're looking at rationals, which in your brain should signal that x is in the denominator, okay? So before I get started, if you have not had a chance to start these yet, please make sure you try them on your own first, and then that way you can fast forward to the content and the parts that you actually need help with. So we're gonna get started first by looking at this equation in the form that it's given to me in. I know I'm gonna have to manipulate it. I know I'm gonna have to see like what shifts happened, like where is this graph located? But for right now, I just really want to see like, okay, what can I tell from this form? So the place I want to start is always the horizontal asymptote, or the HA, okay? And this is where we had our memory tool, the Bobo Botten Eats DC. So I'll write this at the top, Bobo Botten. Go back to your notes if you are confused what I mean by that, okay? So first you're gonna figure out is like, which one is this? So if I look at my degree, that's what's gonna tell me which of these to choose. So the degree on top is x squared, the degree on the denominator is x squared, the degrees are the same, so the exponents are the same. I'm gonna divide those coefficients. So my horizontal asymptote is gonna be 2 divided by 1. So over here I'm gonna say, okay, horizontal asymptote y equals 2 divided by 1, which means my horizontal asymptote is going to be at 2. Okay, so that is actually going to be the first thing that I am going to graph. So I will go ahead and do that in a lovely green color. All right, so I'm going to go ahead and sketch this at 2. All right, I've got my horizontal asymptote in place. Okay, cool. Now I need to figure out, all right, what else can I find out in this current form that it's written in? Well, the problem is like nothing. I could try to figure out the x-intercept, but this is a trinomial. I'd like to try to simplify it any way possible. So the only way to simplify polynomial or polynomial is going to be a 2-factor because we know division only cancels out multiplication. So from here, I'm going to factor the top and I'm going to factor out the bottom separately. Okay, so when I factor this, I'm going to have to slide to the right, and I get x squared minus x minus 2 all over x squared minus x minus 12. And then I'm going to keep factoring this down. I get x minus 2, x plus 1. But since I slid that 2 to the right, I need to remember to divide to the left. And then this is going to be over x minus 4, x plus 3. Simplifying these down, I get y equals x minus 1, 2x plus 1, all over x minus 4 and x plus 3. All right, so at this step, I can notice a few things. So my brain should know, oh, in factored form, like I know I don't want this denominator equal to 0 because that would be undefined, right? So there's 2 things that x cannot be, otherwise this would be 0. And that means x cannot be 4 and x cannot be negative 3. All right, we've talked about why that is. If you cannot remember, please send me an email and I will walk you through it one-on-one. All right, so from here I have x equals cannot be 4 and x cannot be negative 3. So something is happening here. When I go to my calculator, it's going to say error, 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 error at that point. So it must mean that it's either going to be a hole or an asymptote, some sort of discontinuity. The only thing that makes a hole is if these factors cancel out and I'm left with 0 over 0. So that must mean that both of these are actually vertical asymptotes. So there is no hole because nothing canceled out. And both of these are going to be asymptotes. So I'm going to have one at x equals negative 3 and one at x equals 4. And then from here, I'm going to go ahead and sketch those. I'll do that in another color. Cool. So that's going to be at negative 3, 1, 2, 3. And at x equals 4, 1, 2, 3, 4. All right, so the graph is not going to touch either of these lines, the pink or the green at this point. So now the last piece of information, I got to figure out like, okay, what does my graph look like? And this is where things are going to get like a little bit tricky because I need to figure out like where are these points located on the graph. The x-intercept will help me. The y-intercept will also help me. So I want to use, at this point forward, I want to use the simplified equation that I've made. And I know that to find the x-intercept, I just need to plug in a 0 for y. So then the x-intercept, I'm going to plug in a 0 for y. And I get x minus 1 times 2x plus 1. Now, you can bring your denominator down when you do this, but you know you're going to end up multiplying. Well, 0 times anything is just going to be 0. So I'm just going to set the numerator equal to 0. Just save me some time because basically I've already canceled out these denominators. So now I'm left with x equals 1 and x equals negative 1/2. So these are both my x-intercepts. So x equals 1 and x equals negative 1/2. All right, the last thing I can try to figure out, because I don't know much about the shape of this graph. I don't really know what's happening here. So what I'm going to do from here is I'm going to say, okay, let me find my y-intercept. So similarly, for y-intercept, I'm going to plug in a 0 for x. So I'm going to do that in the numerator and the denominator. So I get negative 1 on top, and I get 1, and then I get negative 4 and 3 when I sub that 0 in. So that's going to give me 7 over negative 12. I'm sorry, that was a negative 1 times 1, excuse me. That is a negative 1 over negative 12, which is just 1/12. All right, so the y-intercept is right here at 1 over 12. Okay, what's interesting now is because nothing canceled out, do you remember how we talked about there can be multiple functions here? So I know that this is a rational because x is in the denominator, but it's actually also a quadratic. I have a quadratic on the top and I have a quadratic on the bottom. That is going to cause this graph to do some weird, funky things. So at this point, if you have your graphing calculator, I would go ahead and just sketch that in your calculator to save you some time. If you do not, what you would have to do is you'd have to make your XY table. So I'll come over here on a whiteboard. If you don't have a graphing calculator, you can also Google search. Desmos has a really good, I'll write that down here so you can have it. Desmos has a really good graphing calculator app. So you can go to Desmos and you can graph this so that you can see the actual shape. If you have a graphing calculator, I would plug in at this point. Otherwise, you're going to have to make an XY table and substitute random values for X to then solve for Y to find your points. So like, I already know I'm going to need to plug in a point that's over here. So I would maybe try like -8. Well, if I'm already doing -8, I might as well do +8. So my table would be like -8 and +8. And I would sub those X values in so that I can start to see the shape of the graph here. Because I know it's not going to cross here. So it's either going to be going like this or going like this, where it's hitting these two asymptotes. I just need to figure out, is it up here, is it down here? So when I pick this -8, it's gonna tell me. The same thing with the +8. And then I also know it's doing something in the middle here. Well, I can already see that this is the vertex and it's coming back down. This is actually a parabola. So if we think about like, why is this a parabola? It's because it's taking on the characteristics of this quadratic that's happening here. So once again, if that's a lot of information, if you're like, I don't know what's happening, pick your points, plug it in, and find the shape up here, or just graph it on your calculator or graph it on Desmos. Like, we're not trying to get accurate, like 800 points by hand. All right, so from there, I'm gonna go ahead and fill in the graph. So it's gonna look like this. All right, so we've got a parabola in the middle, and then I've got both of my arms actually going up. Why are they both going up? They're both in the upper quadrants 1 and quadrants 2, because I have two different quadratics. Think about how the arms of the parabolas go. They either go in the same direction or different directions. We looked at this a while back, but that's why they're both going up, like in the two higher quadrants. And then this one is another parabola down here. So that's just why this one looks a little funky. Like I said, check in your calculator. I just kind of want you to understand why it's taking on that shape, but we don't need to be spending, an hour trying to graph that by hand. All right, so now the domain and range are going to be slightly different just because this is a kind of wacky graph. So the domain is going to go from -infinity to +infinity, right? But there's a few places it goes left to infinitely, and then it hits this point, then it keeps going, hits this point. So it's everything except for these two values, which is exactly what we saw in the denominator. So we write that as all real numbers except x cannot be negative, it's right over here, -3 and 4. -3 and x cannot be 4. All right, and then the range is similar, but actually different. Like I do go down forever and up forever, but I have this like weird gap in the middle here because it's not touching this line and it stops actually right here. So this one is, I'm gonna write it a little bit different here. So it actually, the range goes from -infinity. So I go down, and then I'm going to stop right here at this y-intercept, which we found was 1/12. So from -infinity to 1/12, feel free to write that as a decimal. So then it goes from -infinity to 1/12, and it actually touches 1/12. So we'll do a bracket there. And then it skips a little bit, and it starts back up at 2 again. It starts back up at that horizontal asymptote. So then it's going to pick back up at 2, but it's open parenthesis at 2 because it doesn't actually touch that 2. So that's an open parenthesis. Okay, so a lot happening here. They are not all this intense. So go back and check your work on that one and email me if you have any questions for number 7.